starts.
Good morning, friends. I hope you're all there. I welcome the members, the senior members, the members of the community of naval architects and ocean engineers to this first seminar, the technical seminar we are holding in 2021. This session will be chaired by Mr. K.J.H. Christie, who is the Vice President and the Head of Design at Larsen & Toubro Shipbuilding. He has a wide experience in shipbuilding spanning over 40 years at Indian Navy, GRSC, shipbuilders and engineers, as well as Larsen & Toubro now. During his period, he held various important positions, including Head of Design of the Indigenous Aircraft Carrier at Naval Design, Delhi, Warship Production Superintendent at Cochin Shipyard, and the Director of Shipbuilding at GRSC, Kolkata. Under his leadership, Larsen & Toubro has achieved the distinction of becoming one of the very few shipyards in India to have delivered all their ships with in-house design. This includes the OPVs, the interceptor boats for Coast Guard, a floating dock for Indian Navy, and a high-speed interceptor boat, a set of high-speed interceptor boats for Vietnam border guards. Mr. Christie is a naval architect from IIT Kharagpur and holds postgraduate degree in naval architecture, marine engineering, and mechanical engineering from MIT, USA. So over to you, Mr. Christie.
Yeah, can you hear me? Das Gupta, can you hear me?
Yes, I can hear you.
Yeah, okay, good. Good morning to all and welcome to this webinar, Reviving INA. And my congratulations to the INA team to bring this back. We used to have this long time back, a monthly lecture, but for some reasons it could not happen. And now under pandemic, COVID, it has facilitated us to do this through Zoom. And I think congratulations and a very good, well done. Now, thank you for that good introduction. I hope I don't have to do much to earn that introduction, but I have this very pleasurable job of introducing Commander, Dr. Professor R. Vijayakumar. Now, he is well known to a lot of us, but still I have to go through this introduction process. Now, the very fact that he's a commander, a doctor, and a professor all together, it's a very, not an easy combination. That itself speaks that, how well accomplished he is. He's an assistant professor in ocean engineering at IIT Madras. He joined IIT Madras only in 2016. And prior to that, he was at Indian Navy, where he has served for 21 years. He's a graduate from QSAT and done his PG diploma in IIT Delhi, and he's also PhD from IIT Delhi. Now, during his naval career, he has contributed towards designing of many ships, including P-28, and has been commended well by the CNC and others. And on joining IIT Madras, he has guided 5 PhD projects, 3 Master of Science, and 24 MTech projects, which itself is such a huge contribution in a matter of about 3-4 years. He has published 25 papers in international journals and 50 in international conferences. He is a consultant to many industries, and his field of interest include ship hydrodynamics, ship dynamics, computational fluid dynamics, and other things. Now, I just to depart from the prepared text which was given to me, I can say a few things. First of all, that he's a he comes out a very humble person. Despite his exceptional knowledge, I have dealt with him from L&T. A couple of, we were having some trouble with some of these, fluid flow in the ship, and IIT Madras being very at the back door, we rushed to him. And, before we get into a formal contract, he ensures that the job is completed, the results delivered, and then look at the formalities later. And the most important thing is that he's very, very receptive, the views, like a lot of our people in the industry, we have a lot of things to say. Sometimes the academicians have this little bit problem that they are, they stick to their kind of concept. But he comes out as a very, very humble person. And I would say that if you have any problems with respect to fluid flow, etc., he is the guy to look up to, and then he will deliver the solutions. Now, today we will hear from him the facilities that he is handling at IIT Madras for the benefit of the naval architects as well as the country at large. Vijayakumar, welcome. Please deliver your lecture. Thank you.
Thank you, sir. Am I audible?
Yes.
Okay. Thank you very much, sir, for the wonderful introductions. And I would like to thank Kumar Bakshi, pulled me in the short instead of time, and we wanted to revive the lectures. And as usual, planned for the lecture and had 2 systems ready. There is a technical hitch. It's not allowing me to run the presentation in one of the PCs. So I just shifted it to another PC. Please bear with me. And if the video goes in between, mainly because of the video of my lecture delivery, but the presentation will be running. Please bear with me. Okay. So with this, with the permission of the chair, can I start my lecture, sir? Thank you, sir. So why I will be presenting? My slides are visible. I'll just make the slides visible.
Yes, it is visible, sir.
Yeah, it is visible. Okay. The topic I am going to speak is hydrodynamic testing and research activity at Ocean Engineering Department, IIT Madras. As such, a lot of activities are happening, and I am going to cover very few of the activities which I am used with it or I am linked with it, and I may not be able to cover almost all the hydrodynamic activities. So bear with me, and I am going to put the presentation in 4 modules. The first module will be introduction about our department. The second module will be the facilities what we have got it, and the third module will be on the activities which I am pursuing, and the fourth module is regarding our discovery campus which is going to come up. These are the 4 modules I will be there. And another module, a small module I have got, in which I would like to present what are the recent development which we have done, where we can do enhance our experimental activity.
May I request Dr. Vijayakumar to put
Yes,
your
sir.
in the presentation mode?
Yeah. 1 minute.
Okay.
Is it in the mode?
Perfect. Perfect. Thank you.
Yeah. The department has got the earnest beginning in the 1964 and 1977 it became a center. And then it becomes an excellence in the institute to have a breakthrough in this technology of ocean engineering as well as in the naval architecture. Under the assistance of the Germans in 1984 and 94, this program and this department has lot of facilities which has come up, and almost they were being in contest contact even now to a level that we have got a very large number of facilities which are there. In effect, it is better to say that comparing to any universities or any of the naval architecture department, having 7 hydrodynamic test facility at a single roof, we may be the only one to have it. They may have a bigger facility than us, but not 7 facilities under one single roof. In that way, we are lucky enough to have such a facility. Now, if you look at it, our core expertise as well as the number of faculties which we are, we are a mix of 5 in number of disciplines. One is on the coastal and the nearshore structure one, offshore structures, ocean science, naval architecture, and petroleum engineering. Petroleum engineering was the latest addition which has happened to our ocean engineering department. We are a faculty of 23 plus 2, totally 25 faculties are there, out of which 5 or 6 are about naval architecture. I said 5 or 6 are some are going to retire, and others mostly concentrated on the coastal and civil engineering. We have a faculty from electrical also, and this is the mix, and our activities also going to involve in the mix of this. As per the academic program, what we have is, we have a BTech in naval architecture and ocean engineering. Intake is about 40. And MTech, that is a BTech who can do a dual degree. They can convert the degree into dual in naval architecture and ocean engineering. A total of strength coming to 73 number students have been enrolled in both the BTech and naval architecture, MTech dual degree. Then we have MTech in ocean engineering. The intake is about 12 to 18. Now the engineering has been changed into ocean structures. Then we have run 2 user-oriented program. One for MTech Ocean Technology for NIOT. About 10 number candidates select through GATE and selected by with the NIOT. They do the course. They get either absorbed or they can further pursue their job outside also. Then we have been running one MTech offshore structural engineering L&T course, and for almost 5 to 6 years. Last 2 years, that course has been discontinued. We will be getting revived a little later on. And the latest MTech petroleum engineering has been incorporated, and we have 12 to 15 a number of students take part in that. And every year's MS and PhD program we intake in at the rate of 15, meaning in both 7 to 8 in the 6 semester basis, about 15 in a year. And our total student strength is at present coming around 550, the total student strength. And it is always likely to benchmark yourself and look where you stand in terms of your publications in the field of ocean engineering. So of course, not many institutes are there in India. So we are the number 1. Based on globally, we are number 15. So this is also gives us a motivation. This also gives us a motivation to work hard and then publish much more and get your researchers much more in the ocean engineering, meaning ocean engineering, the field of ocean engineering, naval architecture also. Now coming to the teaching and research labs, what we have. As I have shown in the slides, we have many hydrodynamic testing facilities, supporting laboratory, petroleum engineering laboratory, other research laboratory. I will be concentrating on this presentation more on the hydrodynamics laboratory. As I was saying, we are proud to have it. So the main hydrodynamics laboratory what have is wave basin, towing tank, 4-meter deep water wave flume, 2-meter shallow water flume, 2-meter wave current flume, shallow water wave basins, glass flume with PIP. Supporting laboratory are the instrumentation lab and model fabrication facility. I will be concentrating whatever has been in the left-hand side. Coming to the hydrodynamics laboratory facility, what I am showing is the wave basin. Hope my screen is clear. and the movie is running. Okay. The one on the left hand side, we have a 30 by 30 into 3 meter deep wave uh, basin, which is what I am showing. And you are able to see a boy moving inside. It has got a 53 number of paddle wheels. These paddle wheels can synchronously act and then able to generate both regular, random, as well as directional waves. And we have got a long crested wave maker on the other sides, which can create long crested waves. Both can act in a synchronized and then even a directional wave, which we can generate. I think the video is not coming clearly because I'm seeing the other. Yeah. Some of the tests which we have done it for the certain consultancy work. The video is showing over here. So these vessels have been made that have been docked one over the other has been made in China and it has been getting transported to Norway. These vessels have been tested for its seakeeping quality in our seakeeping basin. I am in my 10th slide. You are able to see my 10th slide?
Yes, we can see it, sir. Yeah.
The 10th slide is showing about the towing tank. And we have a towing tank of size 85 meters, 3.2 meters and 2 meters water depth, which can go up to a speed of 5 meters per second. Okay, the two videos which are showing was one is the planing hull, which has been doing a performance evaluations and resistance prediction of the planing hull in the one. And the second video which has been showing is the underwater where we are able to inject a dye and then able to see the flow around the propeller. Okay, this is one of the workhorse. As on today, we are a building is coming up on top. So this is not functional. The other one is fully functional. And this will be functional from May, from the first week of May, we expect it to be fully functional. Some of the tests which have been in the slide number 11, some of the tests which have been done over here in the left hand top corner is the the paint flow test which have been performed on the model skull. One is on the one which is there yellow in color, and the white in color is the one where we have done it on a planing hull vessels. So we are able to find the flow path along the vessels. The photograph which shows below is the water jet propulsion device being model tested at our towing tank. And this is our the photograph which is there on the top right corner is the one where we are trying to do the finding out the thrust and torque coefficients of the propeller. And the propeller which is along with this nozzle which have been fitted along the hull is shown over here. So other towing tank tests have been shown over here. So we have few of the tests which have been performed. The videos are there. There's a catamaran vessels, wave piercing catamaran, and the surface piercing propellers, and one of the vessels for one of the clients which have been done. The 4-meter water flow, where we can generate, it's a 4 meter in 4 meter in the width and 2.8 meters in depth, and which can have a height of 2.5 meters. And more speciality is that we can, and it has got a in between depth, higher depth, where we can do all the deep water models in that spaces and then able to measure the wave forces which are coming here. We can also even generate the focused wave coming and falling and hitting on these structures and then able to measure the wave. This one. Another workhorse is the 2-meter shallow water flow. Here we can vary the depth and we can go to a depth of even very smaller level and then have the both shallow water waves which can be generated. Most basically it is used for coastal structures and other. This was one of the first initial facilities, I think, which have been came up in 1980s and which has been used quite continuously. Next is another one is 2-meter wave cum current flow, where both waves and the current can be generated. But that is which is beside our 30 meters into 30 meters by 3 meters wave basin. where we have got a false bottom where we can generate the current as well as the wave. So it is 30 meters in length and 2 meters in width and 1.8 meters depth. And this is also have been used extensively. In addition to that, under the aegis of NRB, we got the glass flume fitted. This glass flume also being fitted with the PIV measurement devices, which is non-intrusive devices to measure the velocity and other parameters. And this also has got a wave maker, and a small size models and other things can be done over here. It is 20 meters in length, 60 centimeters in width, and 1 meters in depth. Shallow basin, which have been, this is one of the in-house development. The basin has been developed inside, even the wave maker has been developed inside, and it has been put to use. And this is about 19.7 meters into 16.5 into 1. And the first test itself, which is shown over here, it is being done for one of the US coastal protection zone over here. This is the one which is the first test which has been conducted once after it is being commissioned. It's a fully operational one. And wave paddle and control and wave generator. It's all in-house development, and everything has been developed and even program, everything has been done, maintained by us. Apart from this, under the aegis of Ministry of Shipping, we have National Technology for Center for Waterways and Coast. This is a center which has come up. I have a slides separately for that, and there I will be able to give you briefly. As I said, model fabrication facility. Actually, even for me, when I came and joined here, it was quite surprising when the way they make the models. The models have been made very accurately, both in the wood, initially in the wood, then they converted into FRP models, and quite fast, quite accurate, and that is in-house development. It's quite patentable. I generally tell the faculty and the staff which are there, the method in which they make it is also quite patentable activity. And the models not only we make for us, some of the people who are in and around us who wanted to do the model testing also comes and approaches, and then we make the models for them and deliver them. Some of the instruments, we have the propeller thrust and torque measuring instrument also is listed over here. And along with that, if you want to run the propeller open water conditions and cases, we have the instrumentation. So these are the old projects which have been done in the name for the nation buildings. The Ennur groin field has been designed, and they have been whatever, if you go along to Chennai, the groins structures which are there been designed in IIT Madras. And I think for the INS Virat ski jump, when the modification was done, some of the analysis with respect to its seakeeping and or the stability structures was done over here. And FDN, the mooring system and analysis for the FDN was assistance for some of the consulting firms are given from here. The capsule re-entry system was tested at our Bay Basin. Other coastal protection system in and around the, in fact, we can say that we have the monopoly of having the experience and doing a lot of structural coastal protection structures in and around India. And Professor Krishnakutty is quite active in the fish-like propulsion system for the marine vehicle in order to improve the efficiency of the vehicle. Better to go for fish-like propulsions, get closer to the nature and be more eco-friendly. So there is a team which are working where not only on the mode of propulsions, it could be from the flapping like this or in the other way around, that fish-like propulsion is also being done. And apparently one NRP project is also now there under Professor Krishnakutty as the PA. We have the project where we are making the small fish with the propulsion devices able to 1.2 meter in length is the task to make the fish like object like a fish to propel like a fish. Other protection strategies using artificial reef and layout plan. This was the old reef and different years how this island has been shrinking. The Van Island has been shrinking near the Tuticorin. So they have identified and it is now implemented where an artificial reef of layout all along the island has been generated so that this island will be protected. Wave impact and structural loads. You can clearly see that how the focus wave is coming and hitting the structures and we can be able to measure the waves. wave energy devices, able to focus the wave. This is done on a shallow basins, how this gap area is represent the frontal beam, where it is able to generate the waves, those analysis also. So now I have given you the glimpse of the facilities. Now getting back to the activities which you are doing. I'll open the other presentation. Please bear with me. My slides are visible?
Yeah, it's visible. Sir, can you
Yeah.
make it full screen? It will be useful.
1 minute.
Yeah.
Coming to the research activities of mainly focusing on the research activity, what I am doing it. So I continue forward the certain research activities from the IIT Delhi times, where I was working on it from my PhD to furthermore guiding the PhD. So the activities falls in the mainly in the four category I put it in the form. One is on the ship aerodynamics. Hope my slides are visible. Hello?
Yeah, they are visible, sir. Yes.
Yeah.
I can see it. Yeah.
I'm in the slide number 1. Slide number is not there. Okay.
Yeah.
So ship aerodynamics, which deals with the smoke nuisance problem and the ship halo interface, and certain green ship initiatives, mainly focusing on the drag reduction methodology and acoustic underwater vehicles, works on the gliders. This is also quite passionate. I'm about it, and then develop gliders and certain propeller studies on the acoustic effect, and one more we are working on how to design an efficient propeller for a given field form. Okay. So I will be putting 9 slides on how we are going about it. Quite brief. Any doubts, anything you can ask later. The research topic 1 was ship aerodynamics, quite familiar with the problem faced by the Indian Navy. And while I was in service during that time, I taken up this as my research activity, where we have found that certain objectionable quantities which are coming out of the funnels get entrapped back into the intake. So mainly due to the superstructure cluttering formation or the superstructure, the real estate problem on the superstructure, where you want to position many of these items in the constrained spaces at the same time your funnels not taking that kind of dominance over the mast, where you want to keep all your electronics in the mast. Okay. This activity has resulted in more than 10 to 15 papers and more than and also given a lot of insight into how to avoid such problems. Even now many of the consulting firms approach us and we do work for them, and particularly for the vessel of initially which we have experienced for the vessel of Indian naval vessels, which are the dominant, I don't want to name it, that vessels we are given solutions 10 in number of, it was done by Professor Sheshadri and processing, they gave 10 in number of solutions, out of which even with implementing 2 or 3 solutions they could avoid the problem. Apart from this, we carried forward with the case that what should be the funnel to the mast height ratio and to the velocity ratios that will avoid the problem of smoke nuisance. So that was an important contribution. For an earlier designer, initial design approach, we can go to the curves and then pick up those points. And then if you position your funnel and your mast and the height and the distance between them in terms of, and you choose a velocity ratio, then you will know this vessel will have a smoke nuisance or not. And this paper was published in our INA journal only, JST, and it was quite wanted and many people have bought these papers by paying money. Second study was on the ship helicopter landing on a warships. So this is also a problem mainly for warships where you want to have a helicopter landing. And landing spot is in at meaning again because of the problem of the I'll put it in real estate in the ship superstructure area. You try to have it at the most non-conducive part of the vessel with respect to ship aerodynamics. So at the aft and recess portions where you want to land the helicopter warrior. This has resulted in fact, 3 PhDs and still active research is going on. This is in again with the collaboration with IIT Delhi, where I have done my PhD. I'm still in touch with them. We generally do this research activity and work on that. And we have done many of the research activity to other firms who have been facing this problem and able to give solutions also. It is in collaboration with the superstructures, with the intake as well as with this. So there is both the problem is almost intermixed, where the exhaust from the funnel also can come and interfere with the helicopter landing part. Both the activities being done both experimentally and numerically, and both experiment is carried out in a wind tunnel, and numerical we use normal CFD code to generate and understand the various parametric investigation to avoid the problems of the smoke haloduct interaction problem for the safe halo operations. Again, third problem also related with more to the naval activity, where we have this burble effect. Burble effect is typically the curve which is shown here. When the pilot is coming to land on the aircraft carrier, he experiences a sudden change both in the velocity in the Vx and the Vy and the Vz directions when when he is approaching the aircraft carrier. So sudden there is a loss in the velocity what he is approaches. This makes him to more prone to more dangerous level of landing. So he has to have a good control over that. And this problem of this is quite predominant with respect to the positioning of superstructure and positioning of the other structures which are going to come over here. Our analysis are based on this. We are doing an NRB project under hydrodynamics panel in this. It is currently running now. Is this the problem only for a aircraft carrier without the ski jump or with ski jump is another issue. So we have taken up a model picked up a model from looking at the internet, and then picked up a model and with the ski jump, and experimentation has been done in IIT Delhi, and some of the numerical works already completed there, and some of the numerical works are being done over here to understand this burble effect, and again parametric investigation in finding the locations and how the sharp corners at the different deck, that is the flight deck, affects sharp corners at different areas of the flight deck, affect the flow parameters of the vessels. After coming back here to IIT Chennai, one of the activity, the research activity which I have taken was the focusing on the green ship initiative. In this, we would like to reduce the drag of the vessels. So for the vessels which are going at the fluid number much lesser than 0.2 or even lower than that, that is the slow moving vessels, the frictional drag is a quite dominant one. In order to reduce the frictional drag, how do we induce the air bubble? And then in this induced air bubble, how do we going to stick close to the hull surface, coalesce and form a bigger size bubbles and stick to the surface and able to reduce the frictional drag of the vessels. So the video shows a model of 1:23 scale model which has been run with the injection bubble varying from different flow rates, and model is run from 4 to 8 knots. We are able to find out there is a huge change in the reduction of the ship resistance even at the model scale. The flat plate resistance, they consider that having a reduction of value more than 60% for a flat plate. But for when it comes to ships at certain speeds, the frictional drag is coming down about to 30 to 40% in certain speeds we have found out. But of course, there is a amount of energy which you are going to spend on generating the bubbles and delivering it. So it can come at a certain range of 6 to 10% can be the reduction in the frictional drag, reduction in the total drag of the vessels. Now coming to the vessels which are going at the highest flow number, where the drag dominance is more in terms of way-making resistance, that is coming from 0.2 to 0.5. How do we reduce the drag of the vessels? So we were looking at the fitment of a transom stern flap to reduce the frictional, the wave-making resistance or the total resistance of the vessels. So in order to understand the effect of the transom's stern flap, we have done the extensive study with the respect to the transom stern, how the transom stern as a stern itself modifies the flow. And this modification of the flow, how do you make it advantageous by fitment of the stern? So almost about, we can see that in the corner of the presentations, we can see that yellow and other colors. These were the different stern flaps which have been manufactured with respect to the lens to beam ratio, and then fitted along with the one of the L/B ratio of nearly 7 to 7.5 and full number of 0.3 range vessel. And then we have done the towing test analysis. And we have found out that appropriately certain, in this case, the certain, we can look at the curve over here, certain length ratio of somewhere around almost full length, and the beam approximately 1% of the length of the vessel, and a certain angle we are able to reduce the drag of the vessel. It is specific to every vessels. Our intention is to find out how do you design this for a vessels where we can reduce the friction way making drag of the vessels. And which was done for one of the naval vessels. So, of course, it could not be implemented because of other reasons where they have got some other issues at this time. Otherwise, it would have been implemented and it was in the real life, meaning real implementation in the actual vessel. Apart from this, why only with the stern transom stern flap? Why not with the vane? And studies are being undertaken now with the vane. One of the research scholars is doing the work on the vane, and it has got an added advantage, not only modifying the flow at the stern or changing the pressure profile. Other literatures also specify that it makes a propeller moving, and the propeller cavitation insertion speed shifts little higher. So it has got an added advantage. So it could be one of the possible thought process for any of these vessels which are going at more fluid number greater than 0.2 or 0.24 to think of fitment of simple passive device which will be able to reduce the drag of the vessels. Or if the fluid number is less than 0.2, we can look for fitment of air induced bubble to reduce the frictional drag of the vessels. If the vessel is falling between these two, and then if you want to have a wide range of reduction, then it can be thought of going for the hull vanes. Hull vanes are aerofoil or hydrofoil section just below the stern of the vessels. So research is going on. Many publications also come out on this, and we would like to see being implemented in certain vessels. Now, next part is that looking at the propeller noise, and our study is mainly on the finding out the propeller non-cavitating noise. Of course, cavitating noise is quite dominant, and why non-cavitating noise is that almost all the vessels are designed to operate in non-cavitating regime, and in the non-cavitating regime, if you are going to generate the noise, of course, it's going to increase the signal of the vessel. More than that, the average, this ambient noise of the sea is also rising because of the number of vessels flying over there. Our intention is to study the how is this noise characteristics can be reduced by changing the profile of the propeller in terms of the skew angles in the rake angle, and how this geometry affect the noise. So it's a NRV funded project. We are halfway through it, and we have manufactured 3 number of propellers, DTMB 4119 propeller, and able to characterize its noise. And everything we are trying to do it in our towing tank and the 4-bit flume. So of course it has got its own difficulties in doing the test in these flumes, because we require a cavitation tunnels to perform this test. We are not able to go for the frequency level less than 2400 hertz. That's what we have found out. But the noise levels are quite predominantly high in the lesser frequency levels for the naval kind of application of the propellers. So our intention is to have a validation or benchmarking results from the towing tank for the higher frequency levels. Use the numerical methods, use the numerical methods from the both commercial and our own codes to develop, and then have those for lower frequency, and then have for a particular ship, how do you improve the performance of the propeller without affecting the performance of the propeller? How do you improve the reduce the noise characteristics of the propeller? That is the idea, and we are through it. Apart from this, Professor Ananda Subramanian student who is also working on how to have a propeller with a wake adapted propeller. We both are guiding the student now. So would like to improve upon the our coding part with wake adapted propeller and then study into the noise characteristics of the propeller. Then come to the research topic through. We are working on the two types of underwater gliders. One is on the marine hull form gliders, and another one is on the wings, which are blended wing gliders. These are the two gliders we are working on. The marine conform glider has been designed, and we would like to look for station keeping of the autonomous underwater glider. That is, the glider will take able to be in a place, because as you all know, the gliders are autonomous vehicle which will have very long endurance. It can go up to 6 months without being recharged. So it's a slow moving vessels. So idea is to have this autonomous glider to have a spiral path maneuver, so that it will take a spiral path, efficiently do the spiral path maneuver, where we can station this glider in positions for a long period of time and then do recognitions or any other hydrodynamic observation, whatever function it want to do. So idea is to what are the characteristics, hydrodynamic coefficient, what is the hull form, shapes and location of the wings, which are going to affect the spiral maneuver of the this marine hull form or spiral of the glider. The next one is to keep the glider in the very narrow path of the depth, the narrow depth, or you can increase the endurance of the glider by having the changing the hull form into the blended wing shape of a hull form. So the blended wing hull form, one of the students is working on it, and we have made the model. We have done the find the hydrodynamic coefficients on the our twin tank, trying to evolve the methods and other things where it will have a long endurance in terms, and then keeping the very shorter depth or having a long, able to have a narrow depth tracking possible with these gliders. And of course, there have been a lot of research have been happening on the maneuverability of the vessels, where we do the PMM. We have a working PMM module over here, test module here, which has been recently, many few years back, which has been commissioned. And out of curiosity, how is this maneuvering in the astern motion is getting affected, and is also faced by few of the naval vessels and even other vessels which are going to be there, which are has to traverse both ahead and astern, like ferries and other vessels. How is this astern maneuverability will be getting affected? That we wanted to have a study and the research on it. And this effect of astern maneuverability in the shallow water is another going to be a restricted water is going to be another arm of study. So we are doing that activity also. So with this, I have completed my research activity. I'll stop the presentation here. And then I would like to show you another presentation where a new facility where we are, which is coming up. You are able to see my screen. You are able to see my screen. I am audible.
Yeah, yes, sir. We can see your screen as well.
Yeah.
Thank you.
Yeah. So this is a center which has come up in our department, National Technological Center for Port, Waterways and Coast, under the aegis of Ministry of Ports and Shipping and Waterways. The occasion for coming itself is quite novelty is there, because they have been helping in the Calcutta Port Trust, where the dredging and other activities happens. When they had come for an activity of the dredging, there was a study which had been conducted at IIT Madras, and then it has been submitted. Through that activity, they could save, it was said, they could save about 160 crores per annum So that led to the shipping ministry to have a center in the ocean engineering department so that they could do all the technological or whatever the studies which they are related to it do at IIT Madras. That is why the center has come up over here. It comes under the IIT Madras. So the main focus areas to do research and development and continuous manpower training for them. And then we have to do the technical advisory as a technical advisory for some concept evaluation, consultancy and other. In fact, we are doing 10 projects and for the almost 9 projects for the Ministry of Shipping's Ministry of Shipping. In that, whatever I was saying, the bubble-induced drag reduction was the one of the project under the Ministry of Shipping, where they are looking for, because all the vessels will be flat bottom and moving at a slower speed and shallower region, that is in the shallow regions, how do you reduce the drag of the vessels furthermore? So that is the projects which have been undertaken. So this facility is coming up in our Discovery Campus, which is there in the Tayu IIT Madras, as shown in the figure, and you would have been aware of it. And Government of India has given 1,000 crores to set up the facility. Actually, if you see this, the construction work for the one of the facility, which I'm going to show you down the line, is already began and it will be getting commissioned very soon. The campus will be looking something like this, and the sea is the shallow water basin where I kept putting the mouse, which is going to come. Money is available and construction is almost getting over, and it will be quite soon it will be getting commissions. And another D, which is shown over here. Here we are going to have a very large flume, about half a kilometer in length and 4 to 5 meters in width and 8 meters in deep. And then that is the first phase. The next phase is to have a towing carriage on top of it. So there is a center for large scale model testing has been under the scheme of IOE, which has been approved. And through that, we are looking for the facility. Of course, this will come up very soon, and then rest of the things will be coming up. In the other, this area is mainly for doing the research and research-based activities, and the facilities and all other things are going to come up in that manner, rather than having a regular classrooms which will be conducted in the campus here, and this will be mainly for research activities. 36 kilometers away from the present IIT Madras area. So this is the shallow water basin, quite a large shallow water basin, which I shown the construction is already began, which is going to come up over here. And size is about 90 meters and 65 meters and 1 meter in depth, and the current can generate up to 0.5, and wave makers are all up to 4 seconds and 1 meter wave height waves can be generated, and all I think about 93 paddles, or even I don't know exact 125 paddles I think are going to come up. Exact number I don't know, but all the paddles and everything are being designed and being designed in ocean engineering department, and it will be manufactured and implemented over there. So this is another view of that. Apart from this, in that campus, we are going to have 360-degree full bridge simulator. Actually, we have one full bridge simulator actively being used in the main campus now. That is planned to be shifted over there. Here it is, you can actually see that it is 360-degree full bridge. You can actually see that there is no interlock between them, or there is no disturbances between them. It's all 360-degree, it is completely viewed. And apart from that, there are 2 wing bridges also is given. And if it is going to be assisted and berthed or with the tugs, there are 2 advanced tug stations are also given. It's quite a marvelous facility. Already many projects have been completed, and almost all the major ports and harbor structures are major ports visualization simulations are available over here, and a vessel which is going to come over here can either feel both day and night along with the wave conditions, how is the motions and how it is going to get berthed. One of the projects also is under the aegis in this is to get the hydrodynamic coefficients using PMM and any other methods, and then incorporate those hydrodynamic coefficients into the vessel, so that instead of having the vessels to simulate in the sea conditions and then able to go through it, that is also being undertaken. These are the two facilities which are going to come up immediately in the Discovery campus. It's a night vision of the, of course, they have a lot of field research facilities with the center, and they are also going to be making of autonomous uh, vessel, autonomous boat, which it can do the survey purposes autonomously. It's already been almost, it has been now in the implementation stage. Boat it can go autonomous and then do the depth and other measurements. I will end this presentation here. And the last module, hope I'm not overshooting the time. Recently, this is mainly Professor Ananda Subramanian team, which has set up certain facilities in addition to. You are able to see my screen?
Uh,
Yeah, I am putting it. Sorry.
sure. Yeah, no problem.
Vijay, once in a while, your audio goes down pretty low. So you may just,
Okay.
people have been complaining also a little bit. Yeah, okay, right.
Slides are visible, sir.
Yep, sir.
So, in order to carry out the maneuvering simulations in the basin, we have developed an in-house system of able to have the system so that it be able to do the maneuvering in this one. So either with the turning circle or a zigzag motion. So this development was completely done in-house. I'll just go to the presentation mode. You can see the video. The vessel is performing a zigzag motion. You able to see it? So all the instrumentations and the control systems have been developed in-house for this, which has been done very recently. Previously, we were not having this facility to do it. So this is the with the rudder. It is a Becker rudder. Even the fitment of the Becker rudder. This is actually for one of the vessels in IIT, I think so. Have been designed and it is going to have an effect, and the flap of the rudder will have a certain other angle. It's all have been designed over here. So what happens when this vessel is on the head sea conditions? Experimentation on the head sea conditions. Beam sea conditions. On an irregular sea where it is making the spiral maneuver. This courtesy to Professor Ananda Subramanian and his team. They have made this. Not getting onto the overall system generations. Another one is the challenge of doing the high-speed planing hull that literally require to have a different jig, and then the jig should not be able to give the any disturbance to the actual vessels, which is going to perform the planing hull mode of it. So that was designed and done over here. And we have made, because the center of pressure as well as the center of gravity positioning so important so that the vessels will have the efficient planing. So for doing that, we have made certain arrangements to do it. And you can actually see the video. I'll just show you. The vessel is performing the planing mode. And through underwater video camera, we can actually find out the wetted surface area, how the planing is there, typical planing crafts makes it. You're able to see the video of the planing hull underwater portion. So the type of wave pattern which is generated both numerically as well as experimentally has been predicted well. See this. When it loses its longitudinal stability, it proposing occur, which has been numerically simulated, which we have observed in the experimental condition also. You can see it. Another research was the anti-roll roll tank stabilization, another passive anti-roll tank stabilizations, and the movement of water. You can actually see these two videos where you can see the same vessels. One is fitted with the anti-roll device, another one without the anti-roll device. It's also designed for a vessel which is being built. I think the last one is for the design of the water jet system for an amphibious vessel. 1:3 scale model has been designed and fitted and done the test. It was quite a very high challenge just taken by Professor Anvis of India and his team. They have made this and then able to prove it to them. And the model test was done over here. This is with the water jet in the towing tank. With this, I come to the end of the presentation. Any queries, anything you have? Many more things are being done. Of course, a small tip of an iceberg I just presented. Thank you.
Okay, thank you, Vijay, for such a wonderful presentation. And I can say that a lot of us watching you or seeing your presentation would not have realized that we have such fantastic facilities available, with us. And, I'm sure you will be able, people will take it off from this and then, contact you for more information. So now we have time for question answers. So now kindly post your questions. Now, as far as the way it is, we want to handle it is that whoever the first come, first serve basis. So please project the questions, and Vijay, you can take it one by one.
Yes, sir.
Yeah.
Yeah, so we already have a couple of questions in the question answer box. Let me just go through one by one, and I'll request Mr. Christie to post it to the presenter. So we have a first question from Mr. Mohan Ram.
Okay.
So, sir, are you able to see the question answer, or maybe if required,
Yes,
Yeah,
sir.
one minute, 1 minute. I am able to see that. Yeah. Now here, just one more suggestion that a lot of this may not be really questions per se. There may be some information which is adding to whatever Vijay has said. So in such cases, I mean, the president of the person posing the question, they indicate that this is an observation. Otherwise, people will be just looking for a question within that observation. Okay.
Sure.
So thank you.
Yeah, yeah, thanks, sir. Yeah. Yeah, so we have a first observation from Mr. Mohan Ram uh, uh, s- on the study of funnel smoke. So I'll request Captain Christie to maybe
Yeah,
give his overview. Yeah.
Mohan Ram sir, if you want, you can just add a couple of, very briefly what you wanted to say. You can unmute him. You would like to hear him.
Yeah.
Hello.
Yes, sir.
In 1981, Mazagon Docks built a jacket launch barge. This was used for launching jacket platforms at sea. We made a scale model and tested it out at the basin at the Ocean Engineering Center. It was one of the earliest jobs which was done in Ocean Engineering Center. And high-speed cameras took photographs. And we were satisfied that the barge would be successful in launching. And a few months later, we actually built the barge and launched launch jackets, and we took measurements. And I'm glad to say that the results from the actual launch largely corresponded to the results in the Ocean Engineering Center. I think the model is still, I saw it, the model still somewhere lying in the corner of Ocean Engineering Center some years ago. This is for information.
Okay. Thank you,
Yeah,
sir.
thanks, sir.
Thank you,
Now
sir.
we have the next question from Dr. Ghosh Roy. He would like to know how much of student participation are there in these projects. Dr. Ghosh Roy, you want to add something more? You can do that. Otherwise, Vijay, you may answer the question.
Yes, sir. Sir, most of the projects are, if I put it, it is both the students and the project staff and the faculty. And activities with respect to hydrodynamics test facility has to be a team effort. So it is a team which comes and works, and the team now is formed is such that they don't work only for their research alone. They mutually help each other, because even for running a towing tank, we require a team. That team is all involved. So most of the people knows about what the other student is doing and mutually help. That is how we are doing the most of the project. Whatever the projects which I have shown, totally 15 number of PhD students are working, and only I have only 2 project staff. So that is the strength of that is how the projects are being done.
Okay, thank you. Next one is by Priyesh Saxena. Now he has asked about some stern flaps, which you can read. Also,
Yes,
the most important thing that he's asking whether there are any commercial products coming out of this. Now, I have a similar thing to add to you. Like, what happens is that there is a huge amount of research that goes on in all of your educational institutes. But like somebody from the industry, we are actually not looking at research output per se. We are looking at a product output. Like, for example, I would like to, buy a cavitating, supercavitating propeller or non-cavitating propeller from you. Now, for that, you have to probably tie up with some manufacturers and give us a total solution rather than a research solution, which we will come to you only if we are in big trouble. Okay, so you may address this in that spirit.
Yes, sir. For any commercial application of the product development to happen, a strong research base is required, sir. What we are developing is that requirement of that initially to understand the problem in much detail. Of course, without any product which has been finally come out, there is no value for the. I will not say the value of the research will fruitfulness of the research will come only with the product. So we have taken up the propeller, and one more faculty is also working on making the propellers by instead of casting it maybe with what do you call rapid prototyping. And this rapid prototyping is completely little different. So we are working together. So as and when comes, particularly for a propeller and other things, we should be able to mature in another 4-5 years to make propellers within India, which is little more than 2 meters in 2 meters in diameter. We are looking at such kind of activity there. Now coming only to the stern flap and trim tabs, it is commercially available or commercial. It is commercially being used, exploited for the smaller vessels. However, application for the larger vessels with a fluid number greater than 0.2 is not much is in use, but it has got an effect with the reduction of drag up to 6 to 7% and improving the pressure profile at the propeller location and reducing the noise or increasing the propeller cavitation inception speeds for the propeller is quite promising. So that it can be done, but it is for a particular vessels, it has to be suitably made or suitably researched to arrive at the stern flap sizes in terms of the length and the width and the angle of inclinations, so that the better possible effect can be achieved.
Yeah, now we have Amit Ray asking you really a series of questions. So you can now summarize those questions first, and then probably you can try to answer.
First one is elaborate upon the trials undertaken by underwater glider at full scale. I hope you have a plan to deploy glider design and build at some times. Okay. We are doing on the 2 gliders, this one, mainly on the hull form, and instrumentation will be starting up a little later. The one glider is, the hull form is, of course, to the full scale, only doing all the experimentations. And the second glider, which is blended wing with a restriction on the towing tank and this one, carriages, we are doing 1:2 scale or 1:3 scale model test. So full scale will take some more time. Blended wing, that's what I said in the blended wing. Blended wing is there. We are doing it maybe another 4 to 5 years. We will see how it is coming up. That is the aim. Third question. What methods and tools are using to propeller noise? We are using FWH equations. And please confirm, given a wake field. Oh, that is in the development. For a uniform wake, meaning the varying wake only in the radial directions, we could make some progress. For completely varying wake, it will take some more time. In fact, the geometry could be made for a uniformly varying wake. Question number. Last question of the
and Vijay, some of these questions which requires probably a detailed kind of discussion.
Yes, sir.
You can actually do it offline also. Okay. There is no, because there are a lot of people waiting. Maybe we will move on. Now coming to Parthapadim Chakravarti, he just had a very simple question, so you may just answer, and then maybe move on to MSMK Sharma after that, because we don't want to same person probably asking different questions. Let's give everybody a chance. Thank you.
Okay. So how much time it takes to make a model and model test complete? We take almost 21 to a month to make a model, and model test availability of the tank we will be able to complete maybe in not 30 days or 45 days for only the resistance predictions. Of course, complexity involved when you go for self-propulsion test and the sea-keeping test. Once we resistance predictions may be completed within 10-15 days, then of course sea-keeping and other things, it's about availability of the test facility.
Okay. You can move on to MSMK Sharma is asking about, do you have manufacturing facility? Like, I think it's also linked to the fact that are you actually offering a product? That's also there.
So we don't have a manufacturing facility for propeller, but 160 mm dia is quite simple. So we just make it from outside.
You have a 5-axis machine?
Yeah, please go ahead. MSMK.
Do you have a 5-axis machine? This is to be made on that because of that, the shape of it.
We don't have it, sir. We get it done from outside only.
Okay.
Okay.
I'll get back and I'll get in touch with you.
Yeah, yes, sir, sure, sir. Thank you, sir.
Then you have Ramurthy.
Thank you.
You can address that air bubble technology.
Sir, there are some vessels which are there in Japan, which is being using this bubble injection method to reduce the drag. One of the vessel is already there. We are not having the commercial technology ready for it, but we are only analyzing and finding out how much is really the drag reduction for the lower fluid numbers.
Yeah. Move on to Karthik Dapola.
ATM design and optimize uniform. We are not till now taken up till now, but it can be taken up.
Yeah. Now we can take on Mohammed Salih.
Yes, sir. So thank you, sir. You have asked for the question: is the hydrodynamic test facility of ICAS is accredited? There is no accreditation, sir, but you form a part of the this ITTC facility. I don't think so. Any accreditation is there.
Vijay,
yes, sir.
Vijay, can I just
yes, sir, yes, sir, yes, sir.
clarify what I had in mind? Thank you
yes, sir, yes.
for
Yes,
a very nice presentation. So to be accredited by some professional agency, otherwise, what is the credibility or what is the reliability of the results? That, please don't mind my language, but
yes,
how do you compare or grade these facilities? For example, the results what we get from testing done in IIT Madras versus what is done in NSTL, will it be of the same quality? How do you assess by an independent third party assessing organization? That is what I meant.
sir. We have got, I think Professor Ananda Subramaniam would have been there. He would have been better person to answer. He has done more than 60 to 70 tests, more than that in the case. So I will come back to it. We have our own tested and we have found out the resistance predictions and other things much more. And then it has been given into the, I will come back and answer this.
Yeah, because there are two different dimensions. One, of course, is your professional experience and expertise, yes, as well as your theoretical understanding. But there is also the dimension of the test facility itself. We can understand an academic institute cannot afford to invest so much money to
yes,
have
sir.
a world-class facility. So NSTL may lack the insight and depth of understanding, theoretical, numerical, etc. So that is the issue. Anyway, thank you.
Yes, sir. Anyhow, we are looking into testing the large model. That is why the large-scale model testing facility is coming up. One is in the Discovery Campus, and another even the towing tank also will be in the large-scale testing facility. We'll also will have it.
Vijay, second
yes,
question was, will you be able to undertake a wake-adapted propeller design for us?
Maybe not immediately now, sir. Maybe in another 8 to 9 months, we would have some kind of way through. Now, till now, we could come across the uniformly varying wake. That till here we have achieved. Now, completely varying, meaning every radius the wake is same in that form, uniformly varying wake. That we are able to do it.
This is what theoretical basis is what line theory, lifting surface theory.
Lifting surface.
Lifting surface.
Yes, yes.
Okay, thank you. I have finished my questions.
Yes, sir. Thank you. Sir.
Can I take
yes, sir.
Interruption here? I have been fortunate to see quite a few of these testing facilities, and I have also seen the IIT Madras facility coming up since 1980 and to its present level. And compared to NSTL, IIT Kharagpur, even the ship model basin at St. Petersburg and Marine. Excepting Marine, I think the infrastructure and the knowledge available at IIT Madras is really of a very, very high standard. That is my observation over my professional exposure to all these model basins. Thank you.
Yeah, Vijayakumar, now we have, I think it's Professor Pyarilal, if I understand correctly. Okay, he is asking this question of whether when the CFD will replace tank. I think this is a question with a lot of people have in mind. I have been asking this question for the last 40 years. Okay, but every time the CFD come, they make a bigger model testing basin. So I don't think it is going to go away so early, but you can elaborate. But what I have seen from my experience is that earlier we used to do, say, 20 runs of a model. Now, because of the CFD, they do most of it in CFD, and that 20 runs can be now reduced to, say, 5 runs. I think that's probably what we have achieved. But Vijay, please elaborate. Professor Pyarilal, you want to add something more? Please go ahead. Yeah, otherwise, Vijay, you can take on.
Amir, can you please unmute Mr. Pyarilal?
Yeah, I have requested him to unmute. Sir, if you,
this is Pyarilal. I'm not Professor Pyarilal, but rather his student. I consider as Vijay's senior. I passed out in 1994. Yeah, I'm a partner, and we run an engineering consultancy in Dubai, Great Waters Maritime. We have done quite a lot of tank testing with IIT Madras. One of the tankers being built in Uganda, the tank testing, the model testing was done in IIT Madras, and we are about to award another CFD job. So I was wondering, CFD is largely taking over tank testing. So if you could please elaborate the future, it would be great help. Thank you.
Yeah, surely CFD goes hand in hand with the tank testing nowadays, as Christy sir has explained. And if you don't have the time and to do the tank testing, and or you have a sister vessels which are already done, and you have certain data with that, actually we can do away with the tank testing then, because we can validate all our procedures in the CFD and then do the analysis. If it is a drastic modification is there with the hull form or any other things, better to go for a tank testing. That is my personal experience. Otherwise, if there is a planing vessels which you have got a similar vessels, we could do it, or you have done an experiment and had results, we can validate our results and do the modifications and then go back to tank testing if required. Otherwise, need not.
Thank you.
Yeah, you can go to Amit Kumar is asking, what is it? I didn't understand what is it.
Biomimicry propulsion
Yeah,
for submarine vessels. No, it is all in the smaller sized AUVs, autonomous underwater vessels.
Okay. Now, Captain Mohan Ram is asking something, or he's saying something. If you want to add something more, you please go ahead.
Many problems arise in contractor sea trails. They require quick solution drawn from the database, no time to elaborate testing.
May I ask my question, please? There are two kinds of assistance we need from experts.
Yes, sir.
The development thing, for a new model, make a model test, etc. Second is emergency solutions. These are very awkward situations which occur often at a very late stage of construction. For instance, we had 2 tankers for Iran, which I tested the St. Albans model testing tank in UK much before I joined Mazagon Docks. The model tank used undersized models, so the models had laminar flow. But actually, in the full ship, there was turbulent flow, there was flow separation. That horrible fan tail vibration. The ships are going to be vibrating like anything, they were about to be rejected. We had to find a solution within 3-4 weeks, within a month. Now, have you got a database for such situations? Because that is where I think real value addition comes. That when the shipyard or the builder or somebody runs into serious trouble in any issue, hydrodynamics or aerodynamics, whatever it is, have you got a database where you can look at it and say, maybe this will work, maybe that will work, something you can try very fast?
Sir, we have to build upon it. We don't have till now. we have to build upon in this direction.
Now, Vijay, I just want to add here, like recently in one of the ships, what we were building at Larsen and Toubro, we had run into a problem of seawater suction inlet problem.
Yes.
Now, but we have just, modeled it like as per your past experience, but this had it was a faster vessel. Now, it was not sufficient. Now, immediately we ran to Vijay, and I must admit that, of course, he didn't have the database of my seawater inlet system with him, but that I could provide in no time. So he could actually model it. And despite the pandemic, he could take all the computers home, and he worked 24/7 from home and delivered the results in a matter of 3 days. So if you had to go to somewhere else, it would have taken a month or so. So I would say you are very humble in saying that you don't have the database, but you have done the job at least in my case. So
Yes.
I think you should build a database for ICU cases. Most of these problems are ICU cases. The shipyard is running around like blue-ass fly looking for solutions. I've had the Tuticorin tug, which had a stability problem because of top weight, the Norwegian design. So you find in the shipyard, things go well 9 times out of 10. The 10th time, something like a bolt from the blue strikes you, then you're looking around for solutions. So I would suggest, in addition to your own testing, you must build a database from published information collected so that you have some kind of a ready-made solutions available for people in the shipyards and all can't be keeping that kind of a database. So I think in addition to your own testing, I would suggest you must build a library of incidents. For instance, that Iranian tanker, I found out from an INA 1936 transaction that the same kind of problem occurred when a cross-channel ferry. Then we cropped the propeller by 200 millimeters, full 200 millimeters, and the problem was sorted out. But it was just lucky accident that I found that paper in INA, RINA transactions. So I think an organization like yours, if you want to be consultant, should not only look at steady state long-term problems, but should also build, in addition to your own database, by library, by reference, etc., emergency database. It's just a suggestion.
Thank you very much, sir. Now we move on to Chadda. So he has some observations, but he also is talking about commercial viability. So you may just address that shortly.
We have the facilities. We are doing the test. We have an experience of 30 years of doing the test, and those can be used. We don't have accreditation till now, but we are part of a ITTC tank committee, and we are part of it. And commercial viability rights on board. Obviously. The people who have been doing testing and doing the CFD studies keep coming back.
Okay.
That itself is a...
we have another one from Anashwara Nair. He's asking about test to study the proposing how the test to
study the proposing of a ship.
Porpoising. Okay, sorry. Porpoising of the ship.
Porpoising is for the planing vessels when they lose the longitudinal stability of the vessels. So as you know that it will lose its trimming and the longitudinal stability where at that trimmed conditions, if you actually do your Sabatsky methods itself, we know porpoising angle limitations can come into it. And if you want to do the test, if you position your GA, center of gravity in a position, you do the porpoising. So you have to adjust your center of gravity or arrive at it doesn't get into the porpoising regime. That's a simple case.
Okay. Now we have a series of questions from Muhammad Ashik. I think that's the last person asking questions. So you may address and then probably we can conclude after that.
He's asked, I would like to know how the water jet propulsion test can be carried on, mainly scaling down the mission. I think we can have discussions later on with this. This was a quite challenging one. What kind of experimentation we can do in that 20? It's mainly for the where you have we want to do the without intrusions, we want to do the measurements. We do the 20-meter class rooms activity. Sir, what is the possibility of other institutions exploring this facility or doing programs? It is possible. People are with OU and other things that people are doing, but our test facilities are put to use completely in 24 hours, in 24/7. So finding a slot is very difficult. Even we have to wait a lot for the slots. At least happy that it is being put to use. Many other places they have a facility and it is not put to use. That's all. I think all the questions are yours.
Okay, I think it is nicely done. I think we have addressed everybody. Still, if somebody has got anything to ask, we have maybe a minute or so, so you may ask. Otherwise, we'll conclude. Okay, Mr. Dasgupta, can we go ahead with conclusion now? Then I can just conclude in a few words and thereafter pass it over to you.
Yes, please.
Yeah.
And possible.
Okay. Yeah, I think it's a very well elaborated, well articulated presentation with a lot of graphics, so that we could understand the kind of extensive facilities IIT Madras has got. There's no doubt that all of us, certainly I knew a little bit, but I did not know the extent of facilities they have or they are planning to build. Okay, so in that sense, it is very nice to know all this. And Vijay, you have actually put it in a very, very simplistic fashion. All of us could understand it, but there is a lot of complexity, I can assure you, so that assure the audience rather. And a lot of hard work has gone in. So in that sense, it's a very, very well informed and I would put it that way, useful presentation to most of us. Now, a couple of things, I don't have nothing much to say after such a wonderful presentation. One issue which I, as a customer of all these facilities, what is coming out is that we have facilities in NSTL, we have facilities in IIT Kharagpur, which I keep going to Prakash for a lot of things. Now we have IIT Madras. What still we go abroad with a lot of these things. So what is actually coming out is that while you are giving research solutions, or you will study the problem and give your options, whereas outside when they go, they give you what we need. Because a lot of people in the industry are not really interested in understanding what you do. Okay, we just want to have faith in you that you have done a good job, and we'll blindly take it and put it into our system. So I think you have to basically move into that direction. Now you have touched upon a lot of subjects like greenship, obviously with the oil prices and pollution, etc., being what they are. There is certainly that is something which probably we have to look forward to. And then wake adapted propeller, noise reductions, fantastic amount of topics have been covered. Now under this present initiative of the government, where Atmanirbhar or Make in India, etc., I think it is time for us that we have the knowledge, we have the ability, but what probably is lacking is the product we don't have. So I think we should move in the direction of the product. With that, I just conclude and thank you all for attending this this thing, and over to Mr. Dasgupta for giving the final conclusion to the seminar.
One interruption. Now IIT Madras, we are also getting a lot of orders from abroad. We have done the seakeeping analysis for FPSO and given it. Initially, they used to go to, they have gone previously to Marine, and then they come over here. And they themselves said it was access to the data, what they wanted, we could give them with respect to an FPSO, which I myself am getting. And so there is a lot of influx from the other side we are getting. So sooner or later, we will be able to catch up, and we will be able to do all the model testing for all the Indian vessels also. Yes.
Thank you. Thank you very much. Thank you very much. Firstly, thank you to all the members who have participated in this webinar for which we have taken the, we have been able to take the initiative, and the participation has been very, very active. And special thanks to the senior members like Captain Mohan Ram, Dr. Ghosh Roy, as well as others whom I directly possibly do not know, for making this a grand success. And this success has been due to the excellent presentation made by Dr. Vijayakumar and the excellent way it has been conducted and chaired by Mr. Captain Christie. I think the details to which the span of activities at IIT Madras presented by Dr. Vijayakumar is really amazing. As I earlier said that I had some limited exposure to visiting other testing facilities, and I think excepting possibly the presentation part of it, the quality of the work carried out by IIT Madras and Indian other institutions like NSTL and IIT Kharagpur, as well as our Pune Institute, where we used to go for model testing in the olden days. They're all excellent or equivalent quality. So it's a matter of presentation. It's a matter of convincing the clients, both in the government sector or Navy as well as in the private sector, to ensure that we depend more on the initial skill or our own skills, our indigenous skills that we have developed, and not depend so much on outside. And we do have the skills, we do have the facilities to carry out all this kind of work. My sincere thanks to Amir Ahmed for hosting this on behalf of INA, and Commodore Sujit Bakshi for, he is the secretary, the technical secretary of INA, and is taking a lot of initiatives to carry out various types of work. We are also planning and in the process of revitalizing the JST, the Journal of Ship Technology, which is going to come up in a few months' time. And with this, I hope the future of naval architecture professional activity will be revived again across the commercial and naval sectors. And we do have a long way to go with the initiatives taken by the government of India on Atmanirbhar Bharat, the various types of bills being promulgated, as well as the focus on the blue economy, which is started now. So there's a long way to go for us, and we should keep our chin up and ensure that we provide whatever is required to be given to the country we belong to. Thank you very much.